Greetings! Allow me to show our project, the Morse Code Decoder. So basically how it works is that there are 4 buttons and 2 LEDs and 1 7 segment. This button is used for inputting the Morse code. This is for confirming. This is going to the right. This is going to the left. The LEDs will show you that the text displaying is on the far left or on the far right. Let my friend show you how it works.
Alright, I will demonstrate how to use our Morse code. First, if we want to type SOS, just follow the instruction here.
Since the button is unreliable,
you can also type it one by one. For example, I, J, A, Y, and it can also handle numbers like this, for example.
the circuit is actually pretty simple. We got 4 active high switch, 2 LEDs, and 1 7-segment display. We actually don't have 4 leg switch, we only have 2 legs one, so we cannot use the Arduino recommended way. Instead, we connect 5 volt through the button, then one way directly to the pin, and the other way to the ground, but through resistor, so that most of the current flow through to the pin. The 4th switch was connected to the pin C 0 to 3. The 7 segment was connected to the port D 0 to 6, and then 2 LEDs is connected to port B 0 and 1. That's it. Now, how does the code work? Basically, there are 2 states, during input and not during input. This is determined by a T-bit in the status register. So when the program launches, the first thing it do is it set up the port and stuff. So first it set up like the stack pointer, it set up the direction, and then it set up the pin change interrupt. The reason I'm not using external is because it needs to be able to handle like a lot of buttons. So we have a lot of buttons for this, and external is not enough. Then what it does, it is set up the timer. So I make it run every 10 milliseconds. Then it changes the state to like not during input, so the default state. It set up the pointer to the array buffer and initialize stuff, set the 7 segment display to dash. And then when it's done setting up, it's gonna keep jumping back and forth like it does nothing. It waits for the pin change interrupt. So when a button is pressed or released, it runs this. It checks the state which one are in by checking bit T. And then it calls the appropriate function. There are also this detection. So it uses R23 to check if you're pressing or releasing the Morse code input. The reason I'm not using external is like before. It has 2 little pins for me to use, so we need a custom algorithm to check if it's rising or falling edge. Then it's called it calls a function in input. The first button user is going to be using is a Morse code input, but not during input. So change state for the first time. It set the state by setting T-bit, and then it light up the 7-segment display to indicate that it's in input stage, and then it just light up the LED. This is for confirming that the button is already pressed. It's actually pressed. it sets up the pointer, and then I use -1 here and then add 1 to it later. This is to put a 255 in the byte earlier. This is fine because before the input time there's output display, so it's gonna be deleted anyway. So we have 3 bytes to use there. Now, when you press this, it changes that, and then it jumps back to time counter on main. So time counter, it just increment R22 every 10 milliseconds, and after it reach 255, it just stop and keeps it at 255. There's no need to track for that long. Then when you release the button, it's gonna call falling edge. This, oh my bad. It's gonna call this function. So it sets R22 to 0, so it knows now that you just released it. And then we have this ignore threshold algorithm. So if the last byte is very small, like it has to be a mistake small because the button is very unreliable. It just if it's that small, it just add the one you add now, the one before you, and the one before that together, and put it in the same slot in the array. Then it just if that doesn't happen, you just put the time counter into X pointer. So X is pointing at the input buffer. So what this does is every time you press and release the button, it's gonna put the time since like last interaction into an array. So this practically plot a graph on how the Morse code is inputted. Then when you press input again, it use this one instead because this time you pressed during input, so you don't have to switch the state anymore. And it does very similar thing, but this time it also helps prevent buffer overflow. So if it's too long and it reach the end of the input time deltas, it's just gonna stop and cut it off without you pressing stop. But actually you're not gonna reach that long, so you're gonna press the stop button. So it's clear the t-bit, set the state back, and then this put the 255 into the last section of the graph, so the parser knows that this is the last character. And then it just set up the X pointer again, because this could be changed from like earlier usage, and it sets bit register 24 and 25 to X because X is clearly the link. So this is for checking the link. So the position of X before reset, subtract after reset, you get the link. Then it updates the output display. So basically what this does is it parses the Morse code. Uh, should be around here, yeah. So Y pointer used for output display. So it put it at the first. This one cannot overflow because like let's say in main here, it will overflow into this buffer. But we're not gonna use input time dosa anymore since it's keep getting pushed to the right. So there's no way an output display overflow will catch up. Back to this. Now, it parses Morse code. What this does is it basically calculates it creates a integer representation of a Morse code. So how it works is that we have this code right here. The first 3 bits tells you how many times the button was pressed, and then the rest is for like which button was pressed. Then if it reached the character threshold, so like next character, it's gonna stop, push the current integer representation back into it. Then what it does is after it parses the Morse code, return R16, it basically iterates over this and see which character it is. Then it adds a difference between that and 7-segment display to get the correct display it needs. Then it pushes that into the array. After everything is done, it just reset Y register and then set R22. R22 earlier is used for time counter, but for this state, it's used for keeping the index. You can actually check Y register instead, but this is more optimized because you don't have to check two states and it's easier to keep track. So what's happened next? Then it put the display onto the screen. What it does is it checks if it's on the left edge or check if R22 is 0 and check if it's on the right edge. So check if the length is equal to the index plus 1. Then it lights up the LED. And the last step is just push the 7-segment display in the array into the actual part so it can be displayed. Now basically this is done. You got an array of what to display and then you display the first one. Then we have two more buttons. So go right and go left. Basically it checks like the same as LED. Check if it can go or cannot go. It modify index and change the pointer and then print it again into the display. That's basically what it does. So when you press Morse code input not during input, this one again, it's gonna reset everything.